Welcome to this presentation. We are going to talk about pen testing iOS applications. My name is Annika Meyer, and this is Sebastien Andrivet. We are both co-founders of Andrivet Tools, a Swiss company based in Geneva and specialized in information security. So this is the agenda. We are going to start with some overviews and then some previous researches on the subject, and then the actual pen testing, and finish with a live demonstration. So there are three types of iOS application. There are web applications, native applications, and hybrid applications, such as monotouch or Flash. And we are going to focus on native application today. Native applications are written in Objective-C, which is and optionally with some C or C++. And they are compiled into ARM CPU code, which is quite different from Intel x86 code. So iOS applications are distributed as IPA files, which are simply zip files, and then deployed in app directory, which is the same on Mac OS X. One thing which is important is that executables are always encrypted, even for free application, with something similar to Fair Play, which is using AES, and all applications are signed by Apple. So to study application, you have to decrypt it before, and usually we decrypt it manually with GDB, which is the GNU debugger, and Crackerless is also a solution. It's faster when it works. So as I said before, Objective-C, well, I didn't say it before, is a mix between the C language and Smalltalk. And version 2 of Objective-C was released by Apple with Leopard. Objective-C is a superset of C, and it can also mix with C++. About reverse engineering. So what you will see is that it's not so obvious at first, especially if you never worked with ERM before. It's, as I said before, completely different from Intel x86 CPU code. And Objective-C is also very particular, because when you call a method of an object, when you send a message in Smalltalk and Objective-C terminology, you always make an indirect call. In fact, you call message send function and pass the name of the message directly in a register of the CPU. You can find some scripts and tools about reverse engineering on the internet, but they are often out of date and not working. And the best tool available today is IDA Pro. About data storage, there are different mechanisms in iOS application. The first one, plist, is very used and even sometimes abused. We will see that later in the demonstration. It's in binary or XML. And for more complex data, you have SQLite 3. And secrets and passwords are normally stored into keychain, a storage mechanism that is supposed to be secure, but it can also sometimes be cracked. And of course, application can also use their own binary formats, but even in this case, they are often based on property list. What is very important is that as a user of iPhone or iPad, by default, the backups are not encrypted. So it is possible to extract many data from the backups. So we strongly recommend to change the default and encrypt the backup. In this case, you have to set a password. It's not 100% secure, but it's better than nothing. So now I will show you some previous researches on the subject that you can find on the internet. So Apple is releasing a major version every year of iOS. So things are becoming obsolete very fast. So this document from Foundstone seems promising, but in the end, it's quite disappointing because it assumes a lot. It assumes that you have the source code of the application to pen test. And if you have the source code, it's always better to do a code review instead of a pen test. This one is a white paper from Nicolas Serriot, written in 2010 for Black Hat DC. It's not exactly on the same subject, but it's an excellent source of information about data stored in iPhones. However, it's now a little bit out of date. This one is from Tipping Point. Quite interesting because we use it as a starting point to decrypt application, but it was written in 2009, so it's quite out of date now. And those two are quite different from the previous one because their goal is to teach application cracking. Several parts are obsolete as well because written in 2008 and 2009. But it's quite interesting for reverse engineering. So as you say, to summarize, there are lots of documents available on the web, but almost all of them are already out of date and not always realistic and usable. And this is one of the reasons we are here today. So now we will actually see how our methodology. So here are some steps. We will detail them. The first step is preparing the device. So it's better to have a dedicated device than your own iPhone or iPad because then you can have security risk if you use your own device. So you have to decide then if you want to jailbreak your device or not. Jailbreaking is use an exploit to get full access to the device, but it's forbidden by Apple if you're a registered Apple developer. But sometimes it's mandatory if you want to install some tools on the device to jailbreak it. So, but don't do this again if you have confidential data on your device because jailbreaking disables a lot of security features put in place by Apple and then you can be attacked. So these are some useful tools. I will not detail them here, but some of them we will see in the demo, or some of them are very useful, like GDB, as I said before. New debugger. OpenSSH is required to get a remote shell, and we will use this in the demonstration. And Sebastien also will show you a demonstration with TCP dump. So something which is quite important, there are on every iPhone or iPad there are 2 users, root and mobile, and they all have the same password, which is well known, which is Alpine. So make sure when you do pen testing that you change those, especially if you jailbreak your device or if you use OpenSSH. Otherwise you can be attacked, of course. So next step is set up the workstation. Windows is okay, and it will be the case in this demonstration. We have a MacBook, but it runs Windows 7. But if you have the choice, Mac OS X is better because it's very similar to iOS. If you want to use Linux or BSD, good luck. It's possible, but some tools are only available on Windows and Mac OS X. Some more tools that we will use during the demonstration. I will not go through them here. And then we have also our own tools that are not specific to iPhone or iPads, but useful to pen test iOS applications. We will see them during the demonstration later. So the next step is setting up the network. This is what we used to do when we pen test. So we have we connect the iPhone by Wi-Fi in a separate VLAN, and we isolate the Wi-Fi with a firewall because we don't trust Wi-Fi. Step 4 is the actual pen testing. So there are steps in the steps. So first you install the application from iTunes, and then you have a passive pen test, which is called reconnaissance, where you can do even more sub-steps. And the step C is active. I will focus here on the step B, reconnaissance, and also for the demonstration. Network capture, it's possible to run TCP dump on the iPhone and then transfer the result by SSH to the workstation and open the file with Wireshark, for example. But this is not very convenient because you don't get real-time data. So with a file, etc. So we prefer to see the network packets in real time. And to do this, we connect TCP dump on the iPhone with Wireshark. No, we use Netcat to do this, and Windows pipes, and our own tools, ADV SOC2 pipe. And we will see that later in the demonstration. You can also use the proxy method, and the most simple is to set a proxy on the iPhone settings. And then on the workstation, you can use burp or web scarab, for example. And then there's another proxy method. For example, if the first method is not working because some application, they ignore the proxy settings, or they communicate on non-standard ports or use non-standard protocol, then we created our own interception tools, which is called ADV interceptor. It's a little like a transparent proxy. Instead of configuring the proxy settings as before, on the iPhone, you change the IP of the DNS to point to a DV interceptor, and it will intercept DNS request, create SSL certificate on the fly, and listen to HTTP and HTTPS. Can also be cascaded into burp or web scarab. So in order to intercept SSL traffic, we make a classical man-in-the-middle attack. Most of the iOS applications verify the validity of certificates, so we have to inject our root certificate into the device. You can see that on the screen. on the left. And so this is quite simple to do with a tool by Apple, which is called iPhone Configuration Utility. Despite the name, it's also available in iPad and iPod Touch. It's not obvious because certificates are called credentials in this tool. And now I will let Sebastien explain to you the configuration of the network for this demonstration.
Do you hear me? Yes. Okay, so before the demonstration, I will explain a little bit the setup. I have here a small device. It's a 3G. It's connected by 3G to Swisscom, and it's also a Wi-Fi network, a Wi-Fi hotspot. And I'll connect. This is an iPod Touch. It's not an iPhone, but for this demonstration, it's similar. And I connect this iPod Touch to this Wi-Fi network and my computer here. I will use Windows 7 for the demonstration because I will use some tools which are, I have only one license. For example, IDA Pro, I don't have the license for Windows and Macintosh, so I have to choose Windows for that reason. And on the device, I install a VNC server, which is called Vinci. And this way, we will be able to see the screen of the phone on the iPod Touch in almost real time. And also, I install an SSH server, OpenSSH, so we have a remote shell. I will use it also for to transfer files. And I will start with my first demo. So you see on the left the screen of my phone. I will say my phone, it's an iPod, but I have to say iPhone. So it's not very fast because VNC is not very fast, but for the demonstration, I think it's okay. And I will start with the first application, which is called Password Memory. It's an application, a security application used to hide some secrets, to encrypt some secrets. And you have a PIN code. I will try a PIN. I confirm. And it's invalid. And I will try to find this PIN code. I will try to hack this application. The first thing to do is to find the application. Here I have a remote shell, and the first thing is to find where is the application. All applications are under the mobile account in a directory which is called applications. And like Annika said, they are in a app directory. So this is my application. It's in fact in a subdirectory with a random name. I just have to remember this name. And I will go with WinSCP directly on the file system on the phone. So again, var, perhaps I can magnify. No, it's okay. Do you read? Yes. So in var, mobile, where it is, applications, and these are the files of the application. And if I'm going to library preferences, I have a property list. So user preferences, I will transfer this file on my computer to look at it. This is the file. I double click. And if I magnify a little bit, you see data are apparently encoded in base 64. If you decode, apparently it's really encrypted. But if we go at the end, you see this. It looks like a PIN code. So let's try this. 7, 7, 7, 7. This is the pin code. It's a very classical example of what we found when we pen test iOS applications. Secrets are not stored securely, they are stored in plain text. They make encryptions, but the developer forgets to encrypt the pin code, so it's completely useless. Of course, you need to have an access to this file, but so the point is that the password is not encrypted. The next demonstration is not an attack. It's just to show you how to capture data, network traffic in real time. For that, I will use LinkedIn. So I'm going back here. I don't have a firewall in this case because I'm directly connecting my laptop to the Wi-Fi network, but if you have a firewall, it's not possible to communicate directly from the iPod to the workstation without opening a port. So what we do, because we don't like to open a port from a Wi-Fi network to our LAN, so what we do is we use SSH and we make a remote tunnel. I have already 2 tunnels, one which is for this demonstration and one which is for the next one. So instead of connecting directly from the iPod to my workstation with the IP address of my workstation, I will use the loopback address on the phone. So what I wanted to do is to start a TCP dump and to see the result in Wireshark. I have Wireshark somewhere here. And on the Windows, you can use something which is special. You can capture Ethernet data from a Windows pipe. But you need something to connect TCP dump to this Windows pipe, and that's why we use our own tool, ADVSOC2Pipe. You have some parameters. You have to choose a name for the pipe, for example, shark or hash days, and a port, a TCP port, and I choose 6666. And now I will connect Wireshark to this tool. It's simple. The syntax is a little bit odd because it's a Windows pipe, and I choose hash days. So it's a //. The point is for the local station. Pipe is for the pipe's namespace and the name of the pipe. And if I go back here, I see at the end here that it's connected. And now I'm going to where it is, to my remote shell, and I will do a TCP dump. I will explain the parameters. I just have to type them. The first parameter is to avoid resolving names or this kind of thing. We wanted only the raw packets. -s with 0 is to capture the whole packet, not just the beginning. 0 means infinite in this case. -u is important because otherwise TCP dump will buffer the capture. So it's not what we want to do. We want to see this in real time. This is to output the packets on the standard output. And since I'm doing a demonstration, I'm connected to this iPod with SSH, VNC, and with this port. I want to avoid capturing these packets, and I'm piping this with netcat. So this is a loopback address, but it's in fact a tunnel, and it will redirect this on my workstation. And normally, if I go back here, it's supposed to work. We will try. So I'm going back in my phone. And I will start LinkedIn. It's not working. Okay. Now perhaps I will connect directly both. It's more simple. I have to stop all. I have to get my IP address. It's 100. Okay, I restart. I'm going into Wireshark. No, it's not HDS. Oh. Okay, thank you. Right, and hash base. Okay, and I'm going back to here, but this time I will connect directly. So it's 10, 100. No, it's not connected. Oh, no, it's okay. Okay, I'm a little bit short in time. No, we have 20 minutes? Okay, it's okay. So I will retry again. I don't have a ping here. Oh, yes, I received the connection. Okay. So I think it will work. But yes. I'm too nervous. I have to be more to make this more slowly. So I have to restart everything. Okay. So again, pipe, hash, days. Okay. This is connected, and if I start LinkedIn, oh no, something is wrong. But this time I'm not using the tunnel. Oh, it's okay. No, it's just a little bit slow. I will just display HTTP. Yes, I think, in fact, I'm not connected by 3G, I'm connected by 2G, so you see, perhaps it's why it's a little bit slow. And what you see is that everything is in HTTP, it's not encrypted. LinkedIn is using some HTTPS for the login, for example, but all the remaining is unencrypted. Most of the information in LinkedIn are public, so it's not really a problem, more or less, because you have sessions cookies or IDs or things like that. And you may have some problems with private messages or this kind of thing. So you can play with the application and you see on the workstation the data in real time, and you can use, as usual, see the request, the answer, etc. Of course, this method is useful, but if you have something which is encrypted, SSL for example, you only see the packets, the raw packets. You are not able to see inside the packets. But at least you see all the ports which are used. You see the DNS request. You can make the first reconnaissance of what the application is doing. And the next demonstration, we will look deeper in the packets. We will use a proxy to be able to intercept all, and with a proxy like burp, you will be able to intercept the connection, to modify it, and to see what happens. We will not modify any traffic because we don't have the authorization of the owner of the application. We don't want to attack servers. We want to show only passives. I just want to see what happened on my phone with my data. So after this and this. Okay. So next demonstration is with an application which is called Mobility. Perhaps you know this company. It's not a company, it's some kind of association. If I'm not wrong, they are based here in Lucerne. This is why I choose this application. And this time I will use the proxy method, the first proxy method explained by Annika. So I'm going into the network properties, and I will put the proxy address, which is the address of my workstation. It's 10, not 20. 5555. Again, normally, in this case, I use a tunnel. I'm not connecting directly, but since it was not working well with the previous demonstration, I will do this more less complicated. So now, normally, HTTP or HTTP requests are redirecting to this, which is burp. And we will see that. I have to switch off first the application. Okay. I'm going to my reservations. It's a little bit slow. It's really slow. Oh, I hope this application is working. I will try again. I will just verify my IP address. I know why. Okay, I have to change that. I was not listening on the right port. I was only listening on the loopback because I was supposed to use the tunnel method, so this is why it's not working. So again, yes, and now it's working. So this is my real account. because I'm a user of mobility. And you see the request here. And what is interesting, this is my account number, and this is not my PIN code. So apparently it's encrypted. And when we found this kind of information, we try to understand how it is it's encrypted. It's apparently not a hash because it's very short. So we'll try to understand. And this is what I will do now. I will reverse engineer the application. I will use IDA Pro, the latest version, with a decompiler. I open the application. Like Annika said, the application is encrypted by default. I already decrypt the application. It's too slow. I want to focus on the reverse engineering. And we can try to decrypt, to reverse engineer the whole application. But what I want to do in this precise case is just to understand how it is encrypted, how this PIN code, this password is encrypted. So I have to start somewhere, and a good starting point is to find the string. I will search. I will search the string. If I go back here, the PIN equal something. So this is T. So I'm just I'm not sure you see that well. And this is my string. So this is my starting point. This is a string in the C sense. It's terminated by a null byte. And if I double click, I see this in the file. And IDA is making a label. And what is important with IDA is that it's able to compute the cross references, all the references to this data. So I'm going to the reference, and this is also the same string, but this time it's in the Objective-C sense. This CF string is pointing to the previous string. And again, I will search all the cross references to this string. And this is my code. It is used here. So it's not so complicated to read this, but for the demonstration, I will use a decompiler. So this is the code. The decompiler tries to translate ARM code into C code, and this is my string. And I know that, for example, the third parameter is my encrypted PIN code, and I can rename this instead of V something. I can say encrypted PIN. And going earlier, I try to understand what the application is doing. The application is calling something with the class NSUserDefaults. Is to retrieve the preferences of the application, so the user preferences. So I can rename this to user defaults. And then it calls, it sends a method which is value for key, and with something like password, it's to retrieve the password. So this is the password. And then it sends another method which is data using encoding, and 4 in this context means UTF-8. So it takes the passwords, apparently unencrypted, and it converts it into UTF-8. Most of the time it doesn't do anything, at least in Europe. So it's password UTF-8, and then it calls base 64 encoding. And this is my encrypted pin. It's not encrypted. It's in base 64. So you just have a transformation in UTF-8, which doesn't do anything most of the time, except if you have an accent or something like that. But we have a pin code, so it's only digits. And it is converted in base 64. And I can verify this in burp. If I send this to the decoder, I decode, and this is my pin code. And this is really my pin code. So I will have to change this pin code after this presentation. And and if I'm going back here, I will search again this application. The application is Mobility Finder in this directory. I will just make the same thing than previously with an SCP. It's this. The code I decrypted previously is to read this file. And if, again, I look at this file, you see that the password is in clear text. This is one of the reasons it's dangerous to put password without some hash salts and things like that. Because, okay, it's on this device, but you can make a mistake and you can transmit this password on a Wi-Fi network. Most of the time when you use this to make a reservation, you are not on your own Wi-Fi. You are using a public hotspot or something like that. And the last thing important to show, if you look carefully, this is in HTTP. They are not using HTTPS. So this is completely sent in clear. It's very easy to decrypt. It's very easy to take the control. With these two informations, you can then connect to the website. You can cancel existing reservation. You can make new reservation, and the person will receive the invoice. It's not possible to take the car, because to take the car, you need a physical card to open the car. But at least you can make very annoying things. And it's very typical. We choose applications which are simple to demonstrate. We have only 20 minutes for the demonstration, but it's very typical. We see this kind of problem a lot of time. The security situations of mobile applications, the level of security is very low. And so we have a lot of job. So I go back to the presentation. If you have some questions. Yes? If I contact them, the problem with this kind of application is that it's very difficult to contact people, to find the right people. We are trying to contact them at this moment for not a very long time, but for some time. And in general, it's very difficult. I made also a demonstration, almost the same presentation in Paris with other applications, and I show the SNCF application, and the responsible of the application was in the room, so it was interesting to discuss with him. Another question? No? So thank you. You can find more information on our website. I have 2 Twitter accounts and our email addresses. And thank you.